Okay, let's start simplifying trigonometric expressions, and this is where we start to use our fundamental trigonometric identities on page 514, which we went over in the introduction. For example, it might say simplify tangent of pi halves minus theta multiplied by sine of theta. Well, if I look back there, I say, oh, that's one of my cofunction identities there in 514. And I'll say tangent of pi halves minus an angle is the same as the cotangent of that angle. So I'm going to substitute in the cotangent of theta. And I still have that multiplied by the sine of theta. And then I say, okay, that's simplified, but is there further simplification I can do? I always have to ask that question, because for it to be fully simplified, we have to fully simplify it, okay? And then I say, oh, cotangent, that's the same as cosine of theta over the sine of theta multiplied again by sine of theta. Well, then what cancels? My sine of thetas cancel, and I'm left with the cosine of theta. So the expression tangent of pi halves minus theta multiplied by sine of theta simplifies just to cosine of theta, okay? Or let's do another one here. Maybe they give us something like secant of theta, tan squared theta, plus secant of theta. Guys, and the route forward with some of these isn't always clear. It's going to be a matter of getting into it and trying a few things before you get the hang of like when to use which expression to simplify, okay? The road isn't always clear, okay? So on this one, I'm actually going to use here a Pythagorean here, which I'm actually going to use the Pythagorean 1 plus tangent squared equals secant squared. Well, I don't have a secant squared, but I have a tangent squared. Maybe I can solve this for tangent squared. Well, subtract 1 over, and remember, here's my identity. And I'm going to use that identity to help me simplify here. So when I do that and solve it for tangent squared theta equals secant squared theta minus 1. So what I can do now is I can take what tangent squared theta equals and substitute this in for it in my expression up here. Well, let's do that. Secant of theta, and instead of tangent squared, I'm going to plug in now secant squared theta minus 1 plus secant of theta. Okay, so what did I do? I substituted in using an identity, but first, what did I have to do with that identity? I had to solve it for tangent squared theta, right, by subtracting 1 over. So notice, with those identities, I may actually need to say solve for one or the other before I can substitute in and finish simplifying and do things like that. Okay, so now let's distribute that secant of theta and multiply it through using distributive property. That would be secant cubed theta minus secant of theta plus secant of theta. Well, minus secant of theta plus secant of theta goes to 0, and I'm just left with secant cubed of theta. Okay. Okay, so when you're looking at these, it's not always going to be abundantly clear how you want to say simplify them. And you're sometimes going to have to do some guess and check work to see if that's working to simplify it or not. In this case, you may even have to say use an identity and solve that identity. Maybe instead of it being solved here for secant squared, I went ahead and solved it for tangent squared. And then I substituted in what tangent squared theta equaled, and that let me further simplify until I finally got to my simplified form. So secant of theta times tangent squared of theta plus secant of theta ends up being secant cubed of theta. So the more you get in practice these, the easier it'll get. And it will be a little interesting as you get the hang of using these. And let's just look at another one and see if we can't figure out our way through it. Let's maybe pick one from the book. Okay, so let's look at number 17, say here in the book. Cosecant squared x minus cotangent squared x over sine negative x cotangent of x. Okay, when I look up at cosecant squared x minus cotangent squared x, well, I see almost what could be a Pythagorean, but the Pythagorean one in the book is this: 1 plus cotangent squared x, 1 plus cotangent squared theta equals cosecant squared theta. Well, what happens if I say subtracted this cotangent squared theta over? Well, 1 would be left on this side, and that would be cosecant squared theta minus cotangent squared theta. Okay, and notice now that we actually have that right up here. Well, cosecant minus cotangent, cosecant squared of x minus cotangent squared of x, same as theta here, is equal to 1. So I can simplify that to 1. So what did I do? I used the identity here in its original form, and then I solved it, and I essentially solved it for 1. 1 equals cosecant squared theta minus cotangent squared theta, and I was able to then substitute that value in for the original expression up top. Okay, and then sine of negative x is the same as negative sine x. Let's use then our identity there and bring that negative out front. And how could we rewrite cotangent of x? Well, you've got it, cosine of x over the sine of x. Well, what cancels here? That's essentially the sine x cancels, so I'm left with 1 over negative the cosine of x. Okay. Okay, now what's cosine of x? 1 over the cosine of x. Well, that's the same as the secant of x, so let's do that final step of simplification, negative secant of x. Okay. So we went down to there by canceling the signs with the negative out front, and then essentially 1 over cosine of x is secant of x, and I still have that negative out front, so that'd be negative secant of x. Okay. Okay, so in the beginning here, you're just going to want to get into these and try and get through some of these, and then we're going to practice more of it. And as you practice more of it, you'll get in the habit of which identity you use when. Do I need to maybe solve an identity for something else before I plug in? And that kind of thing. And it's just a matter of doing it, and you'll get the hang of seeing it a little bit. Okay, thank you. Okay, so and I just did a little more of cleaning up of this just so you can see it a little more clearly there. 1 over the sines canceled, 1 over the cosine of x, and the negatives out here. And then, of course, 1 over cosine x is secant x, and that negative then makes it negative secant of x. Okay, thank you.